Our presenter tonight is Brian Fitzgerald, and I heard about this program a while ago. There were other libraries that had it, and I thought, what a great program. This would be fascinating. He is the Director of Science and Education at the Mount Washington Observatory, and they are in North Conway, New Hampshire. He has degrees in Environmental Conservation Studies from the University of New Hampshire and a Master's of Education in Science Education from Boston University. Previously, he was a summit intern and a weather observer educational specialist, helping to deliver educational programs and tours on the summit. He also worked at Blue Hill Observatory and as a naturalist for the Appalachian Mountain Club.
Well, thank you so much, Leslie. Thank you, everyone, for joining this evening. It's a pleasure to be able to speak with all of you, even though I'm nowhere near where all of you probably are joining from this evening. Again, my name's Brian Fitzgerald. I'm the Director of Science and Education for Mount Washington Observatory. I'm talking to you from my office, not the nice snowy Northern Lights lit summit of Mount Washington tonight, though, as Leslie mentioned, I do have experience working on the summit as a former weather observer and run our cooperative weather station in town here in North Conway Village. So still getting to observe the weather, which I love to do. So I'll go ahead and kick things off for the evening by sharing my screen here and would love to share with all of you, well, what's going on top of Mount Washington right now. So you all should be able to see one of my monitors right now. And this is one of our internal pages that is updating all of our current conditions on the summit of Mount Washington and a few other stations besides. And currently what's happening right now, it's a little after 7 o'clock in the evening on Mount Washington. It is currently 20.5 degrees right now, which is like a heat wave at the moment. My goodness, considering how cold it was earlier in the week when we were 31 degrees below zero. So we have seen a 50-degree temperature shift over the last 48 plus hours now, which is quite the swing for the mountain. And at the moment, beyond being nice and pretty warm for this time of the year, we have a wind out of the southwest, and southwest is probably the reason why it's so warm, at 42 miles per hour, gusting to 52 miles per hour in the last 10 minutes. And in the last 24 hours, down here at the bottom, we can see we had a wind gust of 69 miles per hour. Currently, the relative humidity is 100% because we are in the clouds. And so for our weather, we have something coded here called FZFG. That is freezing fog, because we are in the clouds and it is below freezing. So we have fog that is literally freezing to all of the surfaces on the summit right now. And then in addition to that, we have something called BLSN. And if anyone with some educated guesses out there, that is blowing snow. So 40-mile-an-hour wind with snow on the ground is whipping it off the ground and all around like a snow globe up there, raising it to a height of at least 6 feet or higher for it to be considered blowing snow. So we're in the clouds. It's kind of warm for January on top of Mount Washington. We average about, say, 7 or 8 degrees as a daily average temperature, so quite a bit warmer than that. And what you can take a look at here as well, which is a little interesting today, we have something called our Autoroad Vertical Profile of temperature. And so along the Mount Washington Autoroad on the eastern side of Mount Washington, that's how we actually get up and down the mountain, we have remote weather stations starting at the very base, going up about every 1,000 feet or so up to the summit of Mount Washington. So you can actually see this sort of vertical profile of what the temperature looks like as you move up in elevation. And normally speaking, but not always, normally as you go up in elevation, you cool off, usually between about 2 and 5 degrees Fahrenheit for every 1,000 feet. Right now, things are actually looking pretty uniform. So it's about 26 degrees at the base, 28 degrees at about 4,000 feet. So a nice warm layer coming in sort of midway up the mountain, and 21 degrees or so, not much cooler on top of the mountain. And when the winds really relax this time of the year, and even in the summer, we can see on calm, clear nights, Mount Washington can be one of the warmest places in the entire state, which is a little counterintuitive because all of that heat in the evening will radiate back off of the surface of Earth back into space, and that really cold air is a little bit heavier, and so we'll actually sink down into the valley. So sometimes it's actually a lot colder in the valley than it is on the summit, but not typically. So to give you a little bit of a visual of what today's weather looked like, we did have about a ½ inch of snow in the last 24 hours. And that's really not much, just a couple of mountain effect snow showers. This is one of our webcams from today. I won't show you a live one right now because it's both dark and foggy, so you're not going to see much. But this is a quick time lapse of what the weather looked like today. From about sunrise this morning, we've been in the clouds all day long. Maybe you'll see some snow coming into the picture here. But what we're looking at is a camera from our observation tower looking down onto the observation deck on the summit of Mount Washington. You can kind of see some of the concrete bricks here, and otherwise lots of frozen fog, also known as rime ice, coating all the surfaces, and a few little snow showers kind of popping in here and there that gave us that ½ inch of snow today. So a pretty typical day on Mount Washington, save the fact that it's a little bit warmer than normal for today's date. But don't worry, that will change. That does not usually stick around for very long. But otherwise, just a pretty common foggy day on Mount Washington, not much to write home about. So let me go ahead and share my presentation that I have for you this evening and just swap monitors for a second again. And basically what I'm going to be talking to you all about tonight is kind of a little bit of everything, a little bit of an overview of not only the Mount Washington Observatory and the organization, but a little bit of the history of Mount Washington and weather observation on the mountain. Talk a lot about what weather observation really means and what goes into a standard weather observation. Talk about the importance and the value of that data, and then a little bit more about some of our our other very important focus areas, including research and education. So to kick things off, again, I work for Mount Washington Observatory. It's a private, nonprofit, member-supported organization, which is unusual. There are not a lot of nonprofit weather stations across the country or even the globe. In fact, we are really the only fully staffed mountaintop weather station in the Western Hemisphere. So unusual already right out the gate. And our main focus, our mission, our driving interest is to expand and advance the understanding of the forces that create Earth's weather and climate. And so I mentioned some of our focus areas. It's through our weather operations, and that's weather observation and forecasting, through research and product testing projects, and then also delivering educational programs as well to communicate that science to the public. And as a nonprofit, much like the Friends of the Library, we rely on donations. And because our work is somewhat diverse and unusual and unique, we rely on funding sources from all over. So it's a typical question that we get. Because while we do have a contract with the National Weather Service, who essentially pays for our weather data that they ingest and use, it is a very small fraction of our overall budget. And as you can imagine, operating a fully staffed mountaintop weather station in one of the world's most inhospitable places is not exactly what you would call cheap. So there's a lot of fundraising and fundraising drives and programs, program fees, our museum that we operate, sponsorship, all sorts of different funding sources. So as I mentioned, we're going to get into a little bit of the history here, and we can go really far back, maybe to the creation of Mount Washington millions of years ago, but we won't go that far back. We'll just start with at least the people in the Mount Washington region. And the very first people that we're aware of are the Abenaki, the Native American nation, more or less, the groups of individual tribes that made up the Abenaki people of northern New England. And we start here because we want to acknowledge that Mount Washington and even where I'm speaking to you from here in North Conway are the homelands of the Abenaki people. And while they are not as populous as they once were in this area before essentially being pushed out, they still have an ongoing, very important cultural and spiritual connection to this area. And so we want to acknowledge that they've continued to steward this area through the generations. And as you can see on the slides there, Mount Washington was very well known to the Abenaki, not personally because they actually did not travel to the summits or the high peaks in northern New Hampshire for a lot of good reasons. And some of the names there very descriptive, that were roughly translating into things like hidden mountain always in the clouds, I'd say is a very good descriptor of what Mount Washington is. Now, the very first documented ascent of Mount Washington is by Darby Field, who back in the 17th century, in fact, in 1642, traveled from where he was living in Durham, New Hampshire, along the seacoast. He traveled by foot up to Saco, Maine, got in a canoe in the Saco River, paddled all the way upstream, and made it to about present-day Bartlett or Intervale, just south of Mount Washington. And from there, he actually was accompanied by 2 Native American guides who lived in the area. And it was said that he wanted to prove to the local Abenaki chief, Passaconaway, that he wasn't subject to the same rules of the Native Americans, and that, he could, no problem, he can go up and down the summit. But again, the Abenaki and the Native people didn't travel to the summit for a lot of good reasons, but one of them being spiritual. They felt that the summit of the mountain was a realm of divine powers. So Darby Field traveled up and down, not entirely clear what his motivations were, but it was a long time before more Europeans would travel up into the mountains. And for weather-related purposes, it wouldn't be until 1870, the winter of 1870 to 1871, that the Huntington Hitchcock expedition put together a small group of very motivated individuals who wanted to see if it was possible to capture meteorological conditions on the summit of Mount Washington during the winter. And so they embarked up to the mountain, were outfitted with all the food and coal for heat and everything they could possibly get their hands on, including some very early yet modern for their time weather instrumentation. And the Cog Railway had a train depot building on the summit of the mountain in which they sheltered through the winter. And they actually made it through the entire winter, which I can't imagine how difficult the conditions must have been. But it was because of this initial expedition and the relative successes that they had, that they were able to actually motivate and convince the U.S. Signal Service, which is sort of the precursor to today's National Weather Service, to establish regular weather observations on the summit of Mount Washington. And they did that for a little more than 20 years, which is incredible. A little bit different in terms of standards and some of the instrumentation and equipment and measurement that they did, but nonetheless extremely important weather observations that took place during that time. And they were very much born out of being part of the Signal Service and using telegraphs and other means of communication to describe the weather for usually a lot of like commercial or even wartime purposes. Now, it wasn't until after the Signal Service essentially gave it up on the summit for a variety of reasons in the late 19th century. It wasn't until 1932 in which the broader scientific community came together to say, we are going to put together something known as the International Polar Year. So 1932 was established as this International Polar Year meant to motivate scientists to work specifically in polar regions and to learn more about the polar regions on planet Earth. And hey, here's a polar region right in New England's backyard. And it got these 2 gentlemen, Joe Dodge, who's working for the Appalachian Mountain Club down at Pinkham Notch at the base of Mount Washington, and Bob Monahan together to say, you know what, we need to restart weather observation on the summit of Mount Washington. So it was these 2 gentlemen that were very motivated, and with the support of the New Hampshire Academy of Science, who made a large donation for their organization to help establish the very first crew, they were able to get going on the summit of Mount Washington with the support of some very key individuals, including the carriage road owner, also known as the Mount Washington Auto Road, Elliot Libby, who not only allowed them to travel up and down the auto road at no cost, but as you'll see in just a minute, gave the observatory its very first building space to operate in their stage office at the summit. Colonel Henry Teague in the upper right-hand corner, the owner of the Cog Railway, donating coal for that very first winter so that observers had a heating source inside the building. Charles Brooks here, who was the director of Blue Hill Observatory, the very first secretary of the American Meteorological Society based in Boston as well, and became the Mount Washington Observatory's very first president. And he lent the meteorological expertise and training and instrumentation for the brand new observers on Mount Washington. And then Henry Shaw, last but not least, of the General Radio Company, donating radio communications equipment because Joe over here was well versed in radio communications from his time serving actually in submarines in World War I. Now, this was the original crew beyond Bob and Joe. Joe stayed largely down at Pinkham Notch, but was critical in managing the operation and doing communication work from the base. Brought on Alex McKenzie, who had great organizational skills in addition to being sort of the electrical engineer and radio man. And Sal Pagliuca, someone that Joe worked with at the back, within the backcountry hut system of the Appalachian Mountain Club, who came by way of companies like General Electric, had an engineering background, as well as interests in meteorology. So it was this first crew that came up the Mount Washington Auto Road, actually captured here in the lower right-hand corner in this convoy of vehicles in October of 1932. And on the summit, they were doing a lot of shoveling and transporting of coal from one place to another for a heat source within their building. Now, it was only the second winter on Mount Washington for the fledgling observatory that something truly exceptional happened. The wind gust of 231 miles per hour was captured on April 12, 1934, captured in this wooden stage office building here, held down by some chains, though I think those are still largely mostly for show. Withstood 200 plus miles per hour in this building and was captured by the anemometer here, held by observer Wendell Stevenson. And this was actually a weather map just the day before leading up to this event, in which a very strong area of low pressure over the Great Lakes combined with another area of low pressure over the Carolinas, converging over New England and creating an exceptional storm with winds that have still not been matched to this day. Now, as I mentioned, the observers were in the stage office here. There's a replica of this building still on the summit for any of you who have visited before. Depending on when you visited the summit, maybe you saw, if it was long ago enough now, maybe you saw the observatory's second building and the only building that was ever dedicated specifically for the observatory. This was a building built in 1937, affectionately known as the Old House, or another nickname was the strongest wooden building in the world. Largely due to the fact that it was a donated building, including materials from the Cog Railway, who donated railway ties to help with the construction of the building. So when this thing was demolished in 1980, even a wrecking ball and a bulldozer had an extremely hard time trying to dismantle this building. Now, the summit of Mount Washington, I should mention, has gone through a variety of different owners over time. So Mount Washington Observatory actually does not own any property on the summit of Mount Washington. And in 1960, the state of New Hampshire purchased the very tippy top, the summit cone here that you can pretty much see in the right-hand side of the slide, from Dartmouth College. And so the state of New Hampshire created Mount Washington State Park and encouraged the observatory to help reduce some of the buildings on the mountain and actually build a building with the observatory in mind in the Sherman Adams State Park Visitor Center, constructed and finished in 1980. So we now just operate and occupy the furthest sort of right-hand side portion of the building here with our observation tower that was built with us in mind. Now, enough about the history. So what's it like on Mount Washington? What are the stats? What's going on weather and climate wise? Well, this is what is considered the norm. This is our climate normals. These are statistics that are taken at any station across the country. But this is from the period of 1991 to 2020. So in the last 30-year record, we averaged 35 miles per hour the whole year round. In winter, it is windier. In summer, it is less so. If you come up to the mountain in winter time, every fourth day, you can expect a wind gust over 100 miles per hour. You can see we average just 28 degrees Fahrenheit, so below freezing for the entire year. Certainly, we do get warm enough in the springtime, or excuse me, in the summer, but warmer than freezing, but the whole year round is 28 degrees. Quite a bit of snowfall. For reference, so 280 plus inches of snow during a season from July to June. Down here where I am in North Conway, we average about 80 inches of snow. We're not that far away. We're 15 miles south or so. It's still a snowy area, but it just shows how much more snowfall and particularly precipitation in general. They average about 90 plus inches of total liquid equivalent precipitation throughout the year. That figure is about 50 inches in North Conway. So the mountains really creating weather of their own and wringing out all of that moisture that is up in the mountains. And as I was sort of referencing before, we are in the fog just about 2/3 of the time. So 60% of the year, we are socked in the fog. From an extremes perspective, again, mentioned that 231 mile per hour wind gust, which stood as a world record for the fastest wind speed ever measured on planet Earth. Still a record for the fastest directly observed by a human being, but this was surpassed in 1996 by Typhoon Olivia off the coast of Australia. That was a wind gust of 253 miles per hour. Now, the warmest all time since 1932, 72 degrees, essentially room temperature. We've hit that mark just a couple times. 47 degrees below zero, also in that second winter in 1934, and that is not including the wind. And our seasonal snowfall records, for those of you who may have been around and were up in northern New England, 1968 to 1969, by far and away the snowiest winter of all time, over 560 inches of snowfall coming that year. Including one snowstorm that lasted over the course of a few days, bringing 100 inches in one prolonged snowstorm. Okay, so I have to include this because maybe some of you saw this and making the rounds on social media or on Good Morning America or whatever, but just this past Tuesday, I guess that was, on the 11th, we set a new daily record. It's nowhere close to our monthly or even all-time record, which I just mentioned, but 31 degrees below zero. It's not quite so common. Maybe once or twice a winter we'll see 30 degrees below or colder. So this was a pretty cold outbreak. Broke the old daily record there of 29 degrees below freezing. And this photo was comes from the creative genius of one of our observers, Ryan Knapp, who's been on the mountain now for 16 years as our night observer. And he was at the end of a shift. This is breakfast for him, or actually no, dinner, even though it should be breakfast time as the sun is rising. And he took some pasta outside on top of the tower and he waited for about 15 seconds and then he let go of the fork. And lo and behold, it's a magic trick. We have frozen pasta. All right, so I think I've referenced this phrase maybe once already, but I'm guilty of, because our organization will use this as a tagline sometimes, but there's this phrase associated with Mount Washington, home of the world's worst weather. I put a question mark here because, well, is it? I don't know. It's a pretty subjective statement to make, a bold one, and including the fact that Charles Brooks, again from Blue Hill Observatory and other backgrounds, he actually, the way this phrase came about, its origins, is from Charles Brooks, who was writing in Appalachia, the Appalachia Journal back in 1940, that it's probable that there are worse mountains than Mount Washington, but observations do not seem to have been made upon them. So he wasn't even arguing that Mount Washington had the worst weather in the world. But when you take into consideration how frequently cold it is, how frequently wet or snowy it is, and how frequently windy it is, all these things together in their frequency, make for some exceptionally challenging weather conditions. So I think you can make a pretty strong argument for it. But then again, I think San Diego has the worst weather in the world. It sounds so boring, 70 and sunny. That doesn't sound very nice. So why? Why Mount Washington? Why right here in our backyard in New England, we have this peak that is so formidable at a global scale? Well, it has a lot to do with the topography, the terrain of Mount Washington, the mountain effect of its own being has a lot to do with something in physics known as the Venturi effect that we'll talk about in a second. And then again, that sort of frequency piece, where we're located in the country, has a lot to do with why we see the weather as frequently bad as it is. Now, Mount Washington at 6,288 feet is the tallest peak in the northeastern United States. And because our prevailing wind direction is more or less from the west here, air can travel completely uninterrupted at our height for more than 1,000 miles to the west until you find another peak like Harney Peak in the Black Hills of South Dakota. You have to go pretty darn far in every single direction to be able to find a taller peak. So because we are the tallest and such a prominent peak in the Northeast, air can just travel completely uninterrupted. And the first thing it's going to hit is the summit of Mount Washington. So already it's going to be windier on top of Mount Washington. In addition to that, I mentioned sort of the terrain and shape of the mountains. Well, I kind of highlight this because our wind direction is largely from the west and northwest. That's prevailing winds through most of the year, and the strongest winds as well. And Mount Washington here, the little red dot, the northern presidential range, some 5,000 foot peaks here, including Mount Adams, and the southern presidentials kind of form this more or less north to south line of very large mountains. And there are these valleys within Crawford Notch and just to the north that have this great funneling ability to be able to push air through these spaces, and it's going to hit the presidential range here and be forced up and over. That being said, we've recorded high wind gusts in every single direction, including that 231 mile per hour record actually came from the southeast. So up essentially the Mount Washington Valley corridor from the southeast. And then so as far as how physics come into play here, that thing called the Venturi effect, well, essentially all you need to remember here is it's like putting your thumb over the end of a garden hose. Air, in this case, is going to replace water as a fluid. So in this instance, when air is traveling from, let's say, the west to the east, and it's going to hit the side of Mount Washington, it doesn't matter if it's at the surface or a little bit higher up, it's going to hit the side of the mountain and it has to go up and over. It doesn't just stop. And so when it goes and travels up and over the mountain, and it's now actually going to move through a smaller space over the peak here and become compressed between the top of Mount Washington and this upper lid of our lowest level of the atmosphere called the troposphere. The upper lid, it's called the tropopause. And suddenly air has to move through this smaller space. And so we know when you put your thumb over the end of a garden hose, all of a sudden water is moving through a smaller space, there's more pressure, and it has to accelerate out through that smaller space. And so the same thing is happening here, where very low winds or lower wind speeds in the valleys can be quite a bit higher on Mount Washington. I mean, there are some days where you kind of barely notice the wind around here in the valleys. Maybe it's a little breezy, but it's gusting well in excess of 100 miles an hour on Mount Washington. And then lastly, mention that frequency of storms piece. Well, this is a really great project from an intern a few years ago, tracking the most common low pressure tracks across North America. And so all we're tracking here really are, these are the most common storm tracks. So it doesn't really matter if the storms start in the Pacific Northwest, along the Rockies, up from the Gulf of Mexico, up the eastern seaboard. It's all going to end up in New England, more or less. And for those of you, if you spent more than a few days in New England, which I'm assuming most of you have, you're going to see a change in the weather day to day. In fact, it'd be really weird. It'd be unusual for New England if we had really stable weather that didn't change for a long time. So you can think to Mark Twain's quote that I'll butcher here. If you don't like the weather in New England, wait a minute, it'll change. Yeah, it has a lot to do with this stuff. So it's going to be frequently stormy on Mount Washington and see these conditions. Now, in terms of how we operate today, again, we have these different focus areas from our weather operations to the research and product testing projects that we do, and then also our educational programs. And we'll focus largely today about on our weather operations, and even more specifically about our weather observations. So we take weather observations 24/7, 365. Someone is going outside physically into that weather on Mount Washington on the summit every single hour of every single day. And we've been doing that since 1932. So one of the longest running climate records in North America. And for a mountaintop, makes it all the more unique. In addition to that, our observers are completing and disseminating a higher summits forecast for the higher summits above tree line in the White Mountains twice a day. And the way that we operate this, so we have 6 full-time weather observers. They're in 2 different shifts of 3 apiece. So at any time, there are 3 observers on the mountain. 2 of them work the day shift, so 5 a.m. to 5 p.m. usually, and then a night observer that works from 5 p.m. to 5 a.m. So that way we can cover all of the observations across the day and night. And that daytime, we have a little extra help for some of the observers that take on research projects, educational projects, and other maintenance tasks. But again, the sort of bread and butter of what we do are weather observations, and we still have people doing it. And when we're talking about a weather observation, it's just like me asking you, hey, what's the weather like outside right now? Same concept, we're just doing it in a very specific way, using some very specific descriptors in very standardized and routine ways to maintain that consistency, accuracy, and precision. And so it's all the stuff you think might go into describing sort of a snapshot of the atmosphere. This could be temperature, things like wind speed and direction, barometric pressure, precipitation, and a number of other variables in addition to that, which we'll cover in just a second. So temperature, pretty obvious. You would think we would describe the temperature. How warm or cold is it outside right now? What is special about Mount Washington is we are still using glass and mercury and alcohol filled glass thermometers for our weather observation. So the same type of technology, and we see our observer here, Becca, who's looking at our minimum and maximum thermometers within something called our thermo shack. It's just this little wooden shelter that shields the thermometers from solar radiation. There's ventilation to allow good air in here. It's kept in the shades, reflecting sunlight with the white paint. So we'll read these whenever we're in the fog or whenever we're trying to get our 6 hourly maximum and minimum temperatures. But whenever we're in the clear, we can see Rebecca here with something interesting looking device that she's spinning around and around. This is called a sling psychrometer. And essentially it's 2 glass thermometers right next to each other. And one has a little cotton sock at the end of it. We dip it in water right before we go out for the observation. We go outside and we spin it around and round. And through evaporational cooling, just like say you getting out of the pool and on a really windy, dry day and you're feeling really cold, well, we're getting the wet bulb temperature, which is going to be colder than the dry bulb temperature, the ambient outdoor temperature through that evaporational cooling. We combine those together in a calculation and we're able to get our relative humidity and our dew point readings out of this. So we've been using a sling psychrometer since we began operation in 1932, measuring with the same exact devices, the same exact routines and standards, in more or less the same exact locations. Again, really, really exceptional in terms of its consistency and rarity in terms of not only where we are in the region, but just the length of that record as well. Now we are famous for our winds, and so as some of you may be guessing, we don't. Well, maybe you don't think about this, but at any rate, we don't get to use a lot of just standard off-the-shelf anemometers because we run into problems with those. They don't work, and for good reason. This is probably one of the hardiest commercial grade anemometers that we use, called a R.M. Young propeller driven anemometer. It gives us our wind speed from this little propeller going round and round. has a big vane on it. It'll give us our wind direction as well. But this does not work well in icing conditions. So whenever we're in the fog and it's below freezing, we're accumulating rime ice, frozen fog, and sometimes 6, 9, 12 inches of this stuff per hour. So essentially anything that has moving parts that are unheated just becomes one big block of ice, and bring a 100+ mile-an-hour gust along, and this thing is toast. So this is made for clear conditions or for lower wind conditions in which it's very sensitive. So this gets a lot of use in the summertime. Beyond that, though, we have custom-made anemometers that you will not find at any other weather station in the world. These two instruments that I'll highlight, the one that's active on the summit right now, this is a pitot tube anemometer. So this tube sticking out the end, you spell that PITOT. This is the same technology that aircraft use to measure their airspeed. We're just kind of doing it in reverse here. This tube is allowing wind, it's veining into the wind with the big tail on it. It is measuring the physical force, the actual pressure of that wind against a couple of pressure ports on this tube. And by getting that differential pressure, we can equate that into a wind speed. So this pitot tube, this one in particular, has been on the summit now for several years. This is probably generation number 10 or 11 or 12 of this. We've been using this style of anemometer since the 40s. This one at the bottom here is our newest iteration. I'll talk a little bit more about this one later, but this one's undergoing its final testing to take over as the new pitot anemometer on Mount Washington. Now, this is what wind data looks like. There's a digital output from these instruments, which is exciting, but not quite as exciting as our analog output to be, at least in my opinion anyways. This is something called a haze chart, this big circular chart here. This chart shows 24 hours, 1 day's worth of wind speed on one chart. Basically, the way this works, again, it spins once a day, and it has a little pen arm at the end of it that this scale is time. So it tracks the time that these winds occurred. And the closer this pen gets to the outside of the chart, the windier it is. And the more it moves back and forth, the gustier the wind speeds. And so on this day, this is one of the windiest days in the last several decades, February 29th of 2019. We literally saw the pen go off the chart because we captured a wind gust of 171 miles per hour on that day. It actually went over onto another chart and then was also captured digitally as well. So exceptionally windy day, one of the windiest days we've had in a long, long time. Now we measure barometric pressure as well. The reason why we do that, the reason why if you're going to own probably any other instrument, weather instrument in your home, including a thermometer, a barometer is probably the one to own, because it's going to be, at least from a general perspective, tell us the most about what sort of weather to expect. That's because, like we can see in this graphing, this is a barograph. This is showing the trend of pressure over time. When we see low pressure or trending toward low pressure, you can think of that big L on a surface weather map as L for like lousy weather. And the opposite, H, you can think of nice, clear, happy weather, H for happy. And because when we have low pressure, it allows air to rise and eventually cool and condense into clouds, create lots of unsettled weather and precipitation. And so when we see really big swings and changes over a short period of time in pressure, we know pretty severe weather is likely on the way, and usually high winds as well. So we have a digital barometer. We also have a mercury barometer as well, and this is something that we track all the time. On this digital barometer, it shows just about 800 millibars. That shouldn't necessarily mean anything to most of you unless you're really into this stuff. But 800 millibars is about our average pressure. If you were to take that down to sea level and equate that pressure to sea level, it would be about 1,000 millibars. So this is showing how much our elevation actually impacts how much less pressure just from a standard level there is on Mount Washington, about 20% less pressure on the summit of Mount Washington, and therefore maybe about 20% harder to breathe up there. It's not super noticeable unless you're really like running up and down a flight of stairs or something like that. But there is less pressure, therefore the air is less dense and it's a little harder to breathe on the summit of Mount Washington. Now we do collect precipitation, rain, snow, sleet, ice pellets, snow grains, all of that good stuff. And we collect it every 6 hours whenever there's precipitation. And I'd love to just show you a quick video here of observer Ryan Knapp going out on what is one of the most dangerous jobs that our observers face on the mountain, because they are traveling the furthest from the building in order to change out these precipitation cans.
Precip can. A lot of people often ask me what the most scariest part of my job is, and this is probably one of them. The main reason being because I have to fight the elements and everybody's asleep at night, so I really don't have anybody waiting for me if I don't make it back. Now, if winds were high, I'd more than likely wake somebody up to be waiting by the door. But on a night like tonight, where winds are blowing about 90 miles per hour and only gusting to 100, albeit it's strong, but it's not too dangerous for myself. I've been out in these plenty of times. Now, right now we have a northwesterly wind, so we're kind of in the lee of the building, so it's not too bad. But once we get to the end here, we'll feel the full brunt of the winds and slowly make our way out to the precip can, which is in the center of the summit here. And around this corner, this is usually where it's the strongest. Getting out to the picture can is not the difficult part. It's once you make the slump, you have to keep the can upright. On an ideal day, just pull out, put it in the holders here, put the new one in, grab the one you just took out. Staying low. And again, try to keep the can as upright as possible. When it comes down to it, it's best just to fall down on your butt and keep the can upright. And then getting your footing on ice, large chunks of ice blowing at you. Those can be a little bit difficult. Once you get back in the lee of the building, it's not as bad. You can slowly make your way back to the front entrance.
So there's Ryan Knapp, a veteran of 16 years as the night observer on Mount Washington. And as you can tell, a little bit understated there in his bravery or insanity, if you want to put it that way. Ryan here obviously quite experienced with high winds, and it's amazing moving around the summit here is a good example of how high the winds can be in certain areas when you're in protection, when you're out of the protection of certain buildings or features. And in some areas, you really have to hold on for dear life. Now, in addition to all these other variables that require just some very rudimentary and basic weather instruments, our observers are using their own human senses to actually compile a weather observation as well in a scientific manner and trained in a consistent way. But they're still actually the ones who are routinely reporting visibility. So by using the known distances of known landmarks on the horizon or the end of the deck, as we usually see in the fog, our observers are using their own two eyes to report the visibility, to report and estimate cloud types, heights, and quantities, and even help do really simple things like determine what type of precipitation is falling. Because believe it or not, it's really difficult, especially when there's lots of blowing snow, or for certain automated sensors, it's still very difficult for sensors to pick up the differences between things like sleet, snow, snow grains, snow pellets, freezing rain, some of this stuff. It's really difficult. So having human verification there is extremely helpful. And in addition to having people there to kind of like ground truth things as data is being collected to see what is and is not reasonable compared to, say, like an automated station, um, they're there to provide maintenance as well. So again, all of this rime ice and frozen fog that occurs here on the summit, even with heated instruments, our observers are still going up sometimes multiple times an hour to de-ice equipment. So it's an exhausting job, but it's extremely helpful to have human beings there at the station, because if even if this was somehow an automated station, if an instrument went down, chances are in the worst weather, there are cases where someone would not be able to come up for days at a time. So there would be a lot of downtime otherwise because of the severity of the weather. All right, so maybe you've asked yourself the question, well, why? Why are you all doing this? It's expensive, it's dangerous, it's hard work. Well, these are actually some points that came to us from the National Weather Service that's really helpful to have. What is the value? Well, I'll just kind of simplify this and move through a little bit quickly here. But the value essentially, particularly to the National Weather Service, is it is extremely helpful for their forecast models to have what is essentially like a fixed weather balloon in the sky at about 6,000 feet in the Northeast. There's no other data point like this that has this much data, this frequent the data, this high quality the data coming in. And so it's extremely helpful for a number of different scenarios, including forecasting things like freezing rain events, severe weather outbreaks, even fire weather. So exceptionally helpful for a number of those reasons. Additionally, the way a lot of people get to know us is because they're avid backcountry enthusiasts. Maybe they like to hike or ski or ice climb or whatever. Maybe they're visiting us from the COG or the Mount Washington Auto Road. Maybe they're in the search and rescue community. Maybe they're pilots. All rely on our weather data and our forecasting as well, our interpretation of weather models specifically for the summit of Mount Washington and the conditions that they'll bring. And so we produce this 48-hour forecast twice a day.
Wow.
And then I'll just kind of breeze through educational programs briefly, even though this is what's near and dear to my heart as well. We offer a variety of different programs here at the Observatory, including being engaged in a curriculum development project called WeatherX right now. Distance learning programs of all kinds. We operate a summit museum seasonally from May to October. And then we also have a couple different programs I'll highlight briefly. If you're curious, we have a monthly lecture series. It's free. It's called Science in the Mountains. On Tuesday, we'll actually have a speaker join us, Dr. Baker Perry, who led a National Geographic expedition to Mount Everest in 2019 to set up some of the world's highest weather stations on Mount Everest. And we're connected with him through the fact that we actually help test those remote weather stations here on Mount Washington. So we'll be excited to have him speak. That's on Tuesday evening at 7 p.m. You can find more information over at mountwashington.org. And then also, if you are aware of any middle schools in your area, any middle school students, teachers who are interested in free educational resources, every Tuesday at 11:15 a.m., we offer a program called the Virtual Classroom Series, in which we move through topics at the middle school level for weather, climate, and climate change. So you can find out more information at mountwashington.org as well. And then lastly, but certainly not the least important of our focused areas, are our research and product testing that we engage in. There are a number of different images here that show a number of different product testing projects that we do. We work with a number of different companies and organizations that are interested in testing their products in some of the most inhospitable conditions possible. We're essentially like a natural laboratory, if you think about it. Extremely high winds, icing conditions, even the elevation, it's high for New England. And so there's some interesting things we've tested like Keurig coffee machines, even the little pods, the K-cups, have to test the pressurization of those pods at certain altitudes. We test outdoor gear like tents, other outdoor clothing, and then even what you might not find too surprising, but anemometers as well for other companies. If your anemometer does even just okay on Mount Washington, chances are it's going to do just fine in most applications. Here's just a brief list of some of the projects that we are working on at the moment, and some that have been recently completed. But everything from climatology analyses, like looking at our long-term visibility records on Mount Washington and its association with air quality over time, long-term temperature records, in the midst of writing a technical paper about our remote weather stations called our regional mesonet. These are remote stations throughout the White Mountains that we operate and have a lot of expertise to share with the broader community. And then here's another image of that pitot anemometer here, what we're calling the next generation. This was an instrument developed with General Electric and students, engineering students at UMass Lowell, to help us develop a custom new anemometer that had even greater heating capacity for melting rime ice, and for some other technical improvements for this instrument to make a very rugged anemometer. So we're in the midst of our final round of wind tunnel testing with this. We've already tested it on the summit, and we're all set to certify this instrument and get it on the summit as our gold standard wind instrument in the coming months here. Now, I mentioned this project with the speaker that we have coming up Tuesday. Again, one of the more exciting projects we've been engaged in recent years. Still in touch with this team as they rely on places like Mount Washington Observatory to help with the technical expertise for operating weather stations and equipment in extremely harsh conditions. And not to end on a sour note here, but I'd be remiss if I didn't talk about our long-term climate records. And so here, what we're looking at, which was just updated just a couple weeks ago now in the new year, we're looking at our annual average temperature on Mount Washington dating back to 1935. And we can see lots of fluctuation year to year. That is what climate does, it fluctuates. However, when we talk about when we actually smooth this out in terms of what is the overall trend, when we take the long-term look here, we do see warming on the summit of Mount Washington. And in fact, just in the last several years here, 2021 coming in tied for the third warmest year on record. The fourth warmest year was the year before that, and our first and second warmest years coming just in the last couple decades here. Now, what is a little unusual, and Mount Washington's special twist on all this, is while we are warming at the summit, we're warming at a slower rate, a much slower rate than nearby locations, including down at Pinkham Notch, which is just at the base of the mountain. Why? Why is that occurring? Well, a lot of that we really strongly believe and needs more investigation, but the main hypothesis here is, so remember, we're kind of in this rarefied air. We're the tallest peak around. We get to actually get exposed to something known as the free troposphere. Whereas at certain times of the year, we're kind of with the rest of us down at sea level, where we're part of something known as the boundary layer, essentially the layer of the Earth that normally, regularly, day to day responds to the heating of the Earth's surface, this friction and movement of air down at the surface level. Well, that boundary layer in the summer more frequently grows above the height of Mount Washington, but in the winter, more often than not, we are still above that boundary layer area. So we don't see, even on a day-to-day weather perspective, we're not seeing that same diurnal heating and cooling pattern each day. Our weather and climate is actually driven a lot more by upper atmosphere dynamics. So a very unusual thing happening here. And then another paper that had recently been published last year, and the images associated with this slide we're all kind of familiar with the January thaw. Well, the January thaw is coming on Mount Washington too. It happens, but not only is it happening, it's happening more frequently and more intensely when it does incur. So that's unfortunately another finding happening in this last couple years examining the long-term weather records here. Alrighty, so I apologies, didn't mean to end on kind of a sour note, but there's certainly lots to explore, particularly when it comes to the dynamics of weather on Mount Washington and our long-term climate records. Mount Washington stands alone in a lot of different ways, and I feel very fortunate to be able to work right here in New England and such an exciting place and such a meaningful place as well, and how it connects to one thing we all get to share, which is the weather every single day of our lives. And unless you're really hidden underground somewhere, it impacts all of us. So I feel very fortunate to share that with all of you this evening.
Well, thank you for coming. This was great, Brian. I'm amazed that people go up there and are able to do all this. It's really unbelievable.
If you have any questions, I mean, even beyond the work that goes on in Mount Washington, weather or climate related questions, by all means, feel free to reach out. Again, you can find me somewhere, but education@mountwashington.org is my email address, and always happy to connect with the public.